Hey guys, welcome to your Unit 9 Lesson 3 notes on solving quadratic equations by graphing. By the end of the day, you will be able to locate roots of quadratic equations by graphing the related functions. That's cool. What does that mean? Well, basically, you remember quadratic equations, right? They're like x squared plus something something, right? And they always take the shape of a parabola, which looks like a U. Then we say the root of an equation is going to be where it crosses the x-axis. So this is a root right here, and this is a root right here. You don't always have to have a positive and negative one. You might have like two positive guys like that, or they might both be negative. It's also possible that you just have one root like this. If there's only one point where it touches the x-axis, then that's your one root. It might be the case that you don't have any roots at all and it's just floating off anywhere. So you might have one solution, you might have two solutions, or you might have zero solutions. But the roots are where they cross the y, nope, I lied. They're where they cross the x-axis, right there. So that's what a root is. So the solutions of a quadratic equation are called the roots of the equation. They can be found by looking at the x-intercepts. We also call them zeros because it's what x equals to make y equal to 0. If y is equal to 0, we don't go up or down at all on the y-axis. So it's what is x when y equals 0. That's all kind of abstract. Let's look at some examples and I'll show you what I mean. In fact, let's look at this example right here. Do you see these fountains? Do you see how they're all making parabolic shapes? They're all going woo, 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 like that. They all make little parabolas. Isn't that so cool? That's not an accident. Look at this guy. He's like coming out the dragon. If that's a dragon. It's a dragon now. Anyway, they all make parabolas. That's the Buckingham Palace in Chicago. And by Buckingham Palace, I meant Buckingham Fountain. I hope I said fountain. Well, anyway, it has 133 jets through which water flows. The path of the water is the shape of a parabola, as you just saw. And then this function right here models the height of the water, h, after the water has flown a certain distance, d, from the jet. So how far from the jet will the water hit the ground? How far is the distance question? So we're going to put distance as our x, so to speak. That'll be this guy right here. That was a straight line, by the way. There we go. So this will be d for distance, and then this will be h for height. So what we're going to do is we're going to figure out when is it equal to 0. When is the height equal to 0? First, we need to graph our function. So I'm going to put our function rule in the middle here. Negative 2d squared plus 4d plus 6. And we need to figure out what is d equal. Well, I'm going to graph starting to find the axis of symmetry. Remember to find the axis of symmetry that will always be at x equals negative b over 2a. But we don't have an x here. Instead of an x, we have d. So I'm going to get rid of that x real quick. I'm going to say it's at d equals negative b over 2a. And what's our b value? Remember, we always have ax squared plus bx plus c. So our b value, oh, just kidding, wrong tool, is 4. So I'm going to get rid of that 4. That's 4. And our a value is a negative 2. So I'm going to get rid of that negative a. That a is now a negative 2. Negative 4 is the same. 2 over 2 is negative. Oh, hey, that's convenient. That just is 1. So our axis of symmetry is going to be here at d equals 1. That's nice. So we're going to want to pick some values below and above 1. Let's go with the easy ones like 0, negative 1, 2, and 3. That might not be enough, though. It might need to go further. So I changed my mind, actually. Let's make a leap of faith, and let's go up to 4 and see what happens. Remember, we're trying to figure out the hits the ground when h equals 0. That means it's not high at all. It's on the ground right there. Height is 0. So, just like normal, we'll take our negative 2d squared plus 4d plus 6 and replace our d values with what we said d should be. So go ahead and take some time and plug in your d values in here, and we'll see what you get. Starting with -1, I got 0. Oh, hey, that's one of them. We'll want that. Okay. 0 is nice. It just comes out to 6. 1 is also nice. That comes out to 8. 2 is a little bit more tricky. That came out to 6. And then 4, I'm afraid we overshot it because, check it out. 4 squared is 16. -2 times 16 plus 4 times 4 is 16 plus 6. Oh, shooties McGooties. That's going to be -32 plus 16 plus 6. It's -10. That was too far. But that's okay. Now let's graph it and see what we got. So we got -1, 0, 0, 6. I should have been making this graph blue because it's water. Okay. 0, 6 over 1 up 8 over 2 up 6 over 4 down -10. Okay, that's going to be 2, 4, 6, 8, 10. Like down there. That's way too far. Also, for your convenience, I plugged it in. It's 3, 0 as well. So that means essentially when it leaves, it's going up and then down and then hits the ground right there. Splashy, splash, splash, splash. We could, if we wanted to, technically draw this part of the graph right here, but it doesn't make sense because you can't go backwards from your jet. You're leaving the jet. It's like you have your fountain in here, and then the water is squirting out and going up and then down like that. So that's what that looks like. Okay, so we need to figure out, okay, well, how far from the water, how far from the jet will it hit the ground? Well, like I said, it's not going backwards 1 foot. That you can't go backwards. It has to go forwards. So that means it's going to be 3 feet. So it'll hit the ground 3 feet from the jet. Cool, right? So you can graph it and just look at the picture and see where it crosses the x-axis. Yay. And that's how you find the zeros. Because that's when y equals 0. So let's do another one. We need to find the roots by graphing this equation. So your first step is always going to be to find the axis of symmetry. It's always going to be at x equals -b over 2a. So here our b is -10. So that gives us a -10 over 2 times our a. Our a is, oh, there's nothing, so 1. -10 is a +10. 2 times 1 is a 2. That's 5. So our axis of symmetry is at x equals 5. So we're going to make that our middle point and pick some values around it. But guys, let's do some easy values. Let's do easy numbers like 2 and 4 and 6 and 8. I don't know why I think even numbers are easy, but we're going to go with them and see where it gets us. Our function here is x squared minus 10x plus 16. Sweet. So whatever x is, we're going to plug that in, and we're going to see what our f of x, or our y, whatever that is, comes out to be. So we're plugging each of our x values, squaring it, and then multiply it by 10 and subtract it, and then add. 16 to it. So go ahead and say, go ahead and take some time to plug in your x values and see what you get. So I got that 4 minus 20 plus 16 is 0. And then 16 minus 40 plus 16 is negative 8. And then 25 minus 50 plus 16 is negative 9. And now since this is our axis of symmetry, they should be equal. So we should have a negative 8 again. We should have a 0 again. Cool, huh? Was that fun? All right, let's graph it. So go over 2. So we've got our x side to side. F of x is up and down. Over 2, up 0. Over 4, down 8. Okay, downer. And then 5, negative 9. 6, negative 8. And 8, 0. And there goes our graph. Oops. We had a little jolt, but that's okay. We're going for good enough. So our values are, what is x equal when y equals 0? Here x equals 2 and x equals 8. So you can write your solution as x equals 2 and x equals 8, or if you want to save yourself a tiny bit of space, you can do x equals 2, comma 8. And that's fine as well. That's cool. Now, how do we know we did this right? Well, we're called them zeros for a reason. So we take our zeros and we plug them back into our original equation and say, hey, does it equal 0? So here is our original equation. Let's plug in 2 and 8 back in there and see, is it true? If x is 2, does this come out to be 0? Oh, it should be. Equals 0, equals 0. And if x equals 8, does this equal 0? Well, are you guys trying to tell me that 2 squared minus 10 times 2 plus 16 equals 0? Are you sure that 4 minus 20 plus 16 equals 0? Oh, since we're not sure, we're going to put little question marks. Trying to tell me that negative 16 plus 16 equals 0? Yeah, it does. So at least 2's right. What about 8? Are you guys trying to tell me that 8 squared minus 10 times 8 plus 16 equals 0? Are you sure? This is a question we're checking. 16 minus 80? No, that's a lie. 64 minus 80 plus 16, is that equal to 0? Well, since 64 minus 80 is negative 16, negative 16 plus 16, well, those guys are opposites. So yeah, that's 0. Hey, cool, we did it right. How crazy is that? That's not crazy at all. It's math magic. Just kidding, it's not magical. It's mathematics. Okay, well, anyway. Cool, how is this helpful? Well, let's say someone is giving you a riddle. It says, hey, I'm thinking of two numbers whose sum is 5 and whose product is 6. Two numbers that add to 5 and multiply to 6. Well, I don't know. And we could be spending all day guessing and checking, or we can figure it out. So let's pretend for a second that we know what the first number is. Let's just call it, since it's treasure, it's x. Okay, so let x be one of the numbers. So we know that they add to 5. So we know that x plus 5, no, just kidding, x plus the other number, whatever that other number is, that's equal to 5. Okay. So, we also know that we can solve for the second number by subtracting x on both sides. This is the tricky part, right? These x's will cancel out, and we're left with just, okay, the other number, whatever that is, That's going to be 5 minus x. So now we can write an equation. We already used our sum. We know they add to 5. And we know they multiply to 6. So one number times the other number equals 6. Well, our first number is x. And our second number is 5 minus x. And they multiply to 6. So let's distribute that x, we don't even need these, into both terms. That gives us x times 5, which is 5x, minus x times x is x squared, equals 6. Now, we've always been setting things equal to 0 because we're trying to find the zeros. So let's get everything all to one side. In order to do that, I'm going to subtract 6 from both sides, giving us 5x minus x squared minus 6 equals 0. But I like to put my x squared first, so I'm going to just wink, put them right there. And now we've got our quadratic equation. Aha! Now we can solve it by graphing. Cool. Let's go ahead and make our xy table real quick. And I didn't make this ahead of time, so I don't have nice, neat lines to follow. But that's okay. We'll just go for good enough, because honestly, guys, graphs are just for getting you close. So in order to figure out where to start our graph, we need to look for our axis of symmetry. So our axis of symmetry says, okay, well, x equals negative b over 2a. And if we have ax squared plus bx plus c equals 0, our b value here is 5. Oh, I forgot my negative, sorry. And then we got 2 times our a value, which is a negative sign. So it's negative 1. So we get negative 5 over negative 2, which is just 5 halves, which is 2.5. Man, that's kind of gross, but that's okay. We'll just put our middle number as 5 halves, and then we need to find a couple numbers around it. Look at those very not straight lines. We'll deal with it, whatever. So this is 2.5. So let's go with 2 and 0, because 0 is easy. Let's also go with 3 and 4. Cool. Cool. Oh, guys, we haven't been graphing our axis of symmetry. We should. So let's see. Oh, we didn't even plug it in. I'm sorry. We don't know what our x's and our y's are. Well, we know our x's. Now we got to plug our y's in. That'd be a wise choice, wouldn't it? Okay, so we have negative whatever x is, square it, add 5 of those x's, and then subtract 6 away. We're going to do the same process. Whoa, hey, it fit. Nice. We're going to do the same process 5 times, plugging in each of our x values. So go ahead and pause the video and figure out what are those y values going to come out to. Guess what, guys? Those y values come out to negative 6, 0, 1/2, 0, and negative 2. Which means all of my x's are going to be positive. So our y-axis can be, whatever. Let's just do this normal. Can you even see that? Okay, there you go. So just do 1, 2, 3, 4. Why not? And what does y? Oh, y goes down to 6. Okay, 2, 4, 6. And it goes up to 1/2. You know what? I changed my mind. Let's move these guys up. That way we can still do 1s down here. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, let's graph it. We go over 0, down 6. Over 2, up 0. Over 2.5, up a half. Over 3, up 0, and over 4, down 2. Oh, we forgot to graph our axis of symmetry again. Okie dokie, here we go. So our axis of symmetry, we said, is at exactly 5 halves. X equals 5 halves. So we can draw a nice vertical line here, which tells us that our points reflect across this line. Oh, that's so fun. Look at that go. Okay. So if at 4 we have -2, that means at 1 we have -2. And if at 0 we have 6, that means at 5 we have -6. So we've got a beautiful parabola. Look at that go. That is the most U-shaped parabola I've ever seen. Okay, there you go. And while that is a nice parabola, we don't really care about the whole thing. All we care about is what makes this 0. What solves this equation? What does x have to be to make y equal to 0? Well, let's look right at our x-axis. Where is y equal to 0? Y is equal to 0 at x equals 2 and x equals 3. So that tells us that our numbers are 2 and 3. So x equals 2 and 3. Just like that. Cool. Hey, when graphing, look for when y equals 0, where it crosses the x-axis, and have a wonderful time on your homework.